Okay, so today we're going to start talking about section 3.4, which is about measures of position and outliers. Okay, so we're going to have, again, there's going to be 5 objectives all together here, and during this video, we are only going to do the first 3. So we're going to determine and interpret z-scores, we're going to interpret percentiles, and then we're going to determine and interpret quartiles. Again, that will sum up this video, and then tomorrow we will determine and interpret the interquartile range and check a set of data for outliers. So that's coming up tomorrow. Okay, so determine and interpret z-scores. Okay, the z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. We find it by subtracting the mean from the data value and dividing this result by the standard deviation. There is both a population z-score and a sample z-score. So your population z-score is going to be z equals x minus mu all over sigma. And again, remember, I know it's hard to keep track of stuff from one thing to the other. Mu is the mean, okay, and it's the mean of the entire population. Okay, and over on the other side in a second, you're going to have x with a bar. That's your sample mean. Okay, so again, population z-score, z equals x minus mu over the population standard deviation. Again, it says it in the words right above. I'm just going to write pop SD for population standard deviation. Okay, and on the other side, z is going to equal x minus x with the bar. So your x data value minus your mean over your sample standard deviation. So sample SD standard deviation. And when you're talking about a z-score is unitless. Okay, it has a mean of 0 and a standard deviation of 1. That's not really going to come up in any way, shape, or form, but just so you know, you don't have to put a unit on it ever, and that's really it. Okay, so now let's look at an example. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7 inches. Data is based on information obtained from National Health and Examination Survey. Who is relatively taller? Kevin Garnett, whose height is 83 inches, or Candace Parker, whose height is 76 inches. So to answer this question, what we're going to do is we're going to find the z-scores for each of them. Okay, so to find the z-score, again, I'm going to do z equals x minus mu over the standard deviation. Okay, so for Kevin Garnett on the left, okay, his z-score, again, if you look back at the problem on the other side, it wanted us to find, it told us that his height is 83. So that's your x value. So I took out that x and plugged in 83 for that first value. And again, I need my minus sign. Okay, and again, going back into the problem, again, the first sentence says the mean height for males is 69.1. So I took out the mu and I put in 69.1. Okay, and on the bottom, I need the standard deviation. And right after that, 69.1, again, if you go back and look at the words, it said a standard deviation of 2.8. So I took out the standard deviation and plugged in 2.8. So again, just don't forget when you're doing your math here, make sure you subtract on the top first, hit enter, and then do the divide by. Hey, if you try to do it all at once, it's fine. Just make sure you put the 83 minus 69.1 inside a set of parentheses, or again, your calculator is going to get a wrong answer. Again, follow along in your calculator and make sure you get an answer of 4.96. Okay, so for Candace Parker, we're going to do the same thing. Again, this KG over here just stood for Kevin Garnett. That CP stands for Candace Parker. That's all that is. So we're looking for her z-score now. So in her case, we were told that she was 76 inches tall. So again, that became my x value that I put in for my first thing here. And again, I need my minus sign, and now I need to subtract the mean value for her. So for females, it says again back in that problem that the mean height for females is 63.7. So I took out the mu and plugged in 63.7. And the standard deviation for women on the bottom is 2.7. So I took out the standard deviation and plugged in 2.7. Again, make sure you do that subtraction before you do the divide. Please play along on your calculator and make sure that you get the same answer. Okay, so the person who ends up having the higher z-score is going to be the person who's taller here, or relatively taller. So it's going to end up being Kevin Garnett. So Kevin Garnett's height is 4.96 standard deviations above the mean. Candace Parker's height is 4.56 standard deviations above the mean. Therefore, Kevin Garnett is relatively taller because he's further away from the mean. Objective 2 is to interpret percentiles. This is going to be quick. There's like 2 or 3 slides for this, and then that's it. Then we'll talk about quartiles and we'll be done. So interpreting percentiles. The kth percentile, denoted P sub k, of a set of data is a value such that k% of the observations are less than or equal to that value. So again, if I had, say, if we look at this one, K would be 2%, and then notice here you have that bottom 2% of scores. Okay, again, if you had the 1 here, that would be the bottom 1% of scores. And again, there's lots of stuff going on in here. Just didn't feel like writing all 100 numbers, but if I look up at the top values here, I have 98. So at the 98th percentile, again, there's only 2% of scores that lie above that, or 98% that lie below it. Okay, however you want to look at it. And again, the 99 percentile, there's only 1% above it, or 99 that are below it. So the Graduate Record Examination, the GRE, is a test required for admission to many U.S. graduate schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score of no less than the 70th percentile for admission into their Human Genetics MPH or MS program. Interpret this admissions requirement. Okay, so all that means in general, the 70th percentile is the score such that 70% of the individuals who took the exam scored worse, and 30% of the individuals scored better. Okay, in order to be admitted to this program, an applicant must score high or higher than 70% of the people who take the GRE. Put it another way, the individual's score must be in the top 30%. So again, your percentile, you have 70th percentile, 70% scored worse, 30% scored better. So for objective number 3, we're going to determine and interpret quartiles. So quartiles are really a form of percentiles. They're just going to be very specific percentages that we're looking for. Okay, so quartiles divide data into fourths, or 4 equal parts. Again, think of a quarter. Think of a dollar. A dollar has 4 quarters. Think of a football game. A football game has 4 quarters. So that's why it's being split into 4 equal parts. Okay, so the first quartile, which is denoted Q sub 1, divides the bottom 25% of the data from the top 75%. Therefore, the first quartile is equivalent to the 25th percentile. Again, if you had 1 quarter, you'd have 25 cents. So you can remember it that way. The second quartile divides the bottom 50% of the data from the top 50% of the data. So the second quartile is equivalent to the 50th percentile. Okay, so the 50th percentile, again, if you had 2 quarters, you would have 50 cents. So that's where the 50th percentile is coming from. And again, what this is going to be equal to, back a few sections ago, we found the median, and the median was the middle number. It split your data into the top half and the lower half. So the second quartile, so Q2, is also the same thing as the median. Okay. And then we have our third quartile. Again, think of 3/4 of a dollar. If you have 3/4, you'd have 75 cents. So the third quartile divides the bottom 75% of the data from the top 25% of the data, so that the third quartile is equivalent to the 75th percentile. And this is kind of graphically what it would look like. Okay, so you have your smallest data value on the left, your largest on the right. For me, the way my brain works, I always like to talk about the median next. So that would be Q2. And then if we cut that median in half, we would find Q1. And then if we cut the top half of the data in half, we would find Q3. So finding our quartiles. So here's our steps. We're going to arrange the data in ascending order, just like we had to do with the median. The data must be in order if you're doing it by hand. When you move into the calculator, your data does not need to be in order first. You can put it in any order and your calculator will automatically order it for you. But we're going to do this first one by hand. Second thing, we're going to determine the median, okay, or the second quartile. You have to find that first. It's not an option. Okay, you always have to find the median before you find the first quartile or the third quartile. Okay, and then step 3, we're going to divide the data set into halves. The observations below or to the left of M, the left of the median, and the observations above the median. The first quartile, Q1, is going to be the median of the bottom half of the data. So again, we're just going to ignore the top half of the data, look at the bottom half of the data, and take the median of that data. Then we're going to do the same thing for Q3. We're going to ignore the bottom half of the data. We're only going to look at the top half of the data, and then we're going to take the median of that. So here's our example. A group of Brigham Young University, Idaho students collected data on the speed of vehicles traveling through a construction zone on a state highway where the posted speed was 25 miles per hour. The recorded speed of 14 randomly selected vehicles is given below. So we want to find and interpret the quartiles for speed in this construction zone. Okay, so again, the first thing that we're going to have to do is we're going to have to order that data from smallest to largest. So here it is, your data values from smallest to largest, and now let's find our median. So the first thing I'm going to do is count the number of scores. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 14 scores. That's an even number of scores. That means that our 7th and our 8th score, I'm going to have to take the average of the 7th and the 8th score. So again, if I count 1, 2, 3, 4, 5, 6, 7, and 8. So your 7th and 8th score is the 32 and the 33. So to find your median, we're going to take 32 plus 33 and divide it by 2. And that's going to give me 65 divided by 2, which will be 32.5. So the median of your set of data is going to be 32.5. Okay. What's happening there? That median is happening between those two numbers. It is not equal to 32. It is not equal to 33. It is between the two numbers. So now when I go to find my first quartile, okay, I'm only interested in the bottom half of my data. So I'm going to ignore all these data values to the right, and I'm only concentrating on what's to the left. And I am including that number 32 in the bottom half of my data. Again, why? Because 32 is not the median. The median is above 32. So to the left of my vertical squiggly here, there are 1, 2, 3, 4, 5, 6. There are 7 data values there. So 7 plus 1 divided by 2, 8 divided by 2. The 4th score there is going to be your median. So 1, 2, 3, 4. Your first quartile is going to be 28. Okay. For your third quartile, we're going to take the top half of our data. So this time we're going to completely ignore what's to the left, and we are only looking at what is to the right. And again, we are taking that 33 and including it in our data for the top half because 33 was not the median. We used it to find the median, but it's not the median. So on the top half, I have 1, 2, 3, 4, 5, 6, 7. So I have 7 scores again. So the same thing is going to happen. We're going to have our 4th score is going to be the median of the upper half. So if I start at 33, 33 would be my first score, 34 is my second, 36 would be my third, and 38 would be my fourth. So my third quartile there is going to be 38. Again, have to find your median first, then find your quartile values. Okay, and on the next slide, I'm going to give you the interpretation of what those are. because it also said to find and interpret. All we did so far is find. So now let's talk about what those interpretation means. Okay, again, the data was already in ascending order. There were 14 observations, so the median or the second quartile is the mean of the 7th and the 8th score. Therefore, the median was 32.5. The median of the bottom half of the data is the first quartile, and again, we had found that this was the numbers that were on that last slide, just another way to look at it without all my writing in the way. And if we found the median of that set of observations, you would have gotten 28, and then the top half of the data would have been, again, Q3, which was 38, again, all which we found on that last slide. So our interpretation here, 25% of the speeds are less than or equal to the first quartile, which is 28 miles per hour. And 75% of the speeds are greater than that 28 miles per hour. 50% of the speeds are less than or equal to the second quartile. And again, the second quartile is the same thing as the median. So the median was 32.5 miles per hour. So 50% of the cars are going less than 32.5, 50% are going more than 32.5. Our third quartile was 38. So again, the third quartile is the same thing as the 75th percentile. So that means that 38 for that third quartile, 75% of the cars are going less than that, 25% are going more than that. And that is where we're going to end today. And it's again tomorrow, we'll start with objective 4.